Code reviews. Code reviews are important activity under the implementation, and it could be considered as a kind of a technical review. And uh, Usually when the programmers complete the development of a particular module, uh, and the complete means is there if there is no errors, and if the module is working before they integrate with any other things. And common practice is to conduct a kind of a review. The main reason for this is it's possible to identify some errors in advance by checking the overall structure as well as the how things have been done. In some cases, the testing will take a long or more effort to identify these errors, but the code reviews can easily detect in advance some of the possible errors that may could occur. Usually, the code review should be conducted by the uh, someone who has more experience, uh, or will be have a more good understanding about the particular programming language and the design and the overall. So usually in a senior person. And code review is not a self-review, and it should be conducted by an appointed person by the management. We can code reviews can often find and remove common vulnerabilities. So what do you mean by the common vulnerabilities? The common mistakes people could make it, such as formatting string exploits, race conditions, memory leaks, buffer overflows, thereby improving the software security. These terms will be very new to some of you, so I suggest you to research the details. What do you mean by the format string exploits, race conditions? These are very known uh, mistakes and issues that people encountered when coding using a particular programming language. Please use the discussion forum to discuss these things in detail. So overall, it's improved the quality of the code being reviewed. Okay, so it's not just errors, and also uh, improving the standard, and organize the code in some sort of a good way, and help the programmers to understand how they should conduct the coding activities in a particular project. And at the same time, we'll have to keep in mind this particular review is not a meeting to negatively criticize someone else's code. So usually people can speak in a way saying bringing downgraded the good work that has been done. That is not the thing. Criticize the architecture of the design. So the coding is done once the architecture design is completed. If the people wanted to do the architecture design review, that should be conducted before the code review, and it should not be done during the code review. So that is a common guideline. Code reviews are not a way to criticize the colleague. Different people have different skills and knowledge, and everybody need to help each other in this exercise, and that builds a good friendship as well as a learning environment. Determine whether someone is to be removed from a project or not. A very bad practice. I mean, the code reviews are not to conduct the people to put blame and remove it, and then that will create a very negative effect among the people who will continue in the project. So that will be something else. Determine whether someone is performing up to this standard. Okay. Um, so it's a responsibility, and probably the code review report will be very useful, and it's a kind of a guidance for people to correct their mistakes. If the same thing occurs again and again, of course the management may take the decision. So this code reviews will give a kind of a uh, message to be more disciplined in the implementation process. People should not be careless, and that message also should go into the code review. So usually the code review could have different uh, types of the code reviews. One is called the code walkthroughs, and the other one is called the code inspection. Let's discuss these things in detail. Let's discuss some details about the code walkthrough, which is one type of a code review, usually done by the same members in the team or someone who knows about the project. And it could be considered as an informal code analysis technique rather than the formal thing. So in this is conducted, as I mentioned earlier, when the module is working, no compile errors and all the syntax issues are corrected, so the module is working. And those who are doing the code walkthrough are given the code few days before the walkthrough meeting. So the meeting is where the people will present their findings, present the thing that happens between those who did the walkthrough as well as the people who did the actual coding of the relevant module. And so the people who are reviewing can go through and understand and read it them in advance. Yeah, each member selects some test cases, simulates the execution of the code by hand. So the test cases is a kind of a way to check whether the written code is performing what is expected. Just looking at the code and just reading or browsing the code, it is very difficult to understand things that may go wrong. So most probably the test cases people could decide based on the expected outcome and expected input, and if they can do it, that is the easiest way. Or otherwise based on the use cases, so high level requirements, looking at that, people can identify the suitable test cases. And the team performed in the code walkthrough consists 3 to 7 members. That depends on the size of the project. If there is a larger team, so it could be considered an observation tour, and people are just walking, and those who are seeing whether the work is done properly. So not a deep analysis, but to make sure things have been done according to the common standard and the practices. The code walkthrough uh, could have several objectives. So one will be to discover the algorithmic or logical errors in the code, where uh, sometimes the program may work, but the algorithm usually should be based on the design specification. If the people have understood the algorithm in a wrong way, the coding is not done according to the algorithm. So there may be a mismatch that could occur. So the people may decide those test cases sometimes looking at an algorithm rather than looking at the actual code that is there. So that will help people to identify what we call the logical errors. So the logical errors is due to this mismatch. To consider the alternative implementation, always this something could be done in a different ways. So what would be the best way to do? And if someone else could see you can do in a better way, the usually the people would prefer to have a less number of codes. And the LOC stands for the lines of code. So LOC should be smaller than as much as possible. This will also help the people to reduce the complexity in a particular module. So as I beginning, I mentioned about something called the cyclomatic complexity. The cyclomatic complexity happens when there is a more execution path in a particular module. So reduce the number of execution paths is something people should consider. And in some cases, if people use a different uh, programming approaches, there is a possibility they can reduce the number of number of lines of the code, and especially in the object-oriented mechanism, you will understand how this could be done. The other one is to make sure the team is following the standards and the specification defined by the organization, whether the things are done in a proper way or not. So those three things could be considered as one of the key objectives people should do when they are doing the code walkthrough. The code inspection is the other method of the code reviews which I mentioned earlier. This is a kind of a detailed analysis of the particular segment, module of the code in the code base. And there may be several objectives in this investigation. So that's why we call inspection. The main objective, one of the main aim will be errors detected during the code inspection could be considered as the use of uninitialized variables. So sometimes when the people do the programming in a very hurry, so they don't consider this putting in a value, initial value for the variables. Why that could lead to a kind of problem? A variable means a particular memory location, and it's a hold. So usually the previous, when we declare in a variable in a particular program, and the memory will be allocated for that variable. So then the original value will be there. So if we don't initialize, the variable will carry that value, and if that could lead to some unexpected problem, unexpected behavior, jumps into the loops. So this is another the kind of problem. I mean, if you just it's like jumping or into from into or running a rain or the train, and that would lead to a kind of unexpected big issue, which leads to a kind of a situation where the program will hang and may not be able to follow. And non-terminating loops, and that goes with the indefinite situation, and the people may that depends on the type of the values which are assigned at the very beginning. Incompatible assignments. Okay, if the people assigned, let's say for example, if the variable type is an integer, okay, but if you really wanted to have a real number, and when you assign the real number to an integer in some programming languages, it takes only the real integer part and it drops the decimal part, and that is a kind of a loss of the data, and there may be a completely unexpected result. Array indexes out of bounds. So this usually the array is declared with respect to the number of locations, maybe 10 or 15, but in some cases it may go more than the normal number of size of the array. That lead to a completely unexpected thing. So always whenever the arrays are declared, it should have a kind of an upper bound. Improper storage allocation and deallocation. So this is a kind of a problem usually happens in the what we call the new program using the pointers, and in some programming languages, when things are not used, it should be removed. But that's what we call deallocation. If that is not done, the memory, there will be some sort of a wastage of the memory. If the memory is wasted, the program performance will come down, and there may be lots of technical problem that could happen during the execution. A mismatch between the actual and the formal parameters in the procedural course. So hope you have some experience when we are declaring in a procedure. Usually we have a parameters, those parameters has a particular data type, and when the parameter is called, and usually the data is assigned to those parameters, but the data type of the parameter and the actual assignment value may not match, and some cases that will lead to a kind of a loss of the data, and the output will be totally unexpected. Improper modification of the loop. So the people sometimes modify the loops in a wrong way, like in a jump statement which is usually not accepted. And at the same time, there are different ways the loops could be implemented, but this the most appropriate method should be selected. For example, whether it is in a while loop or whether it is in a repeat until loop, which one is the most suitable. And usually in the repeat until loop, you may know that at least a one time it will execute, but while loop there is a possibility if the condition is not matched, it will never execute it, and the relevant code segment could be skipped in that case. So there will be a lot of tips about finding errors. So I just list some of them because that will help you to know about your programming skills also. Refine the test cases that produce the error. I think it's sometimes the people can develop the test cases that works perfectly correct and no problem occurs and the people will feel it very happy. Always we need to have a test cases that break the code, we could usually call, and then you identified what should be the errors. So always change the test case. That's what we call the refine the test cases. That will create a problem and identify the mistakes. Reproduce the error in a several different ways. So an error could occur in one way, but the same error could be occurred in a different way. So moment you see some sort of an error, try to see whether the same error could be happened in another way. Use the results of the negative test. What do you mean by the negative test? Usually we give the acceptable input when we are testing, but you can have a test cases where you provide the data input data is not expected out of, maybe data type may be different, maybe out of the range, and there may be different ways you can test. And the negative test usually uh, is done to see whether the program can identify the input is not acceptable and it should be not perform and it should not follow the instruction. But this use of the results of the negative test is very important to find the errors. Sometimes there may be lots of things. As I mentioned earlier, this integer real issue, and when the parameter is an integer and if the actual input is in a sometimes in uh, a real number, there may be, depending on the programming environment, there could be a lot of unexpected problem could happen. Brainstorm for hypothesis. I think it's the sometimes the one person will see one thing, another person will see the issue from another point of view. So it's always a good to have a kind of an open discussion. That's what we call in the brainstorm, and see how particular assumption could lead to an error. Narrow the suspicious region of the code. So everything is not perfect. Some areas may be more vulnerable. We may suspect, and the depending on the, if there is several people have contributed for the development of code, and the people really need a kind of confidence about the particular area. Be suspicious of routines that had errors before. Okay, if something has gone wrong earlier, okay, always double check that one. So that is the common suggestion where people could happen in some cases. Check the code that's changed recently. Okay, so probably the recently changed code, that is a new code, it must be checked. That is the common thing. Every code in the code base should be checked. Without checking, if we let something to pass, probably that will lead to a kind of an unexpected problems later. Expand the suspicious region of the code. Okay, so that is if something is wrong in a particular area, probably that may affect the region. Okay, so the things are around that. So it is not only the checking a particular spot, and also check surrounding area. uh, in, Integrate incrementally. Okay, so some errors we will discuss in the testing section. Some errors doesn't occur when we check uh, uh, particular thing. Usually we call the unit testing. But when we start integrating the modules, so the errors could occur. So some of the errors is visible when we integrate with the other things. Check for common errors. Okay, so common mistakes. Okay, I mean that is the easiest way. What would be make the common errors? So sometimes it's possible, and talk to someone else about the problem. Okay, and that's another thing. I mean, the different people can think about the a particular thing, or they may provide an advice and have a different views of the problem. So always try to talk with the others. Okay, and then that will help you to identify the problems more easily. Take a break when checking for errors. I mean, sometimes when you concentrating something continuously, it's natural. I mean, you may not be able to see the error. When you come back on the second time, you can. Some of the things will be obvious, and this is a common uh, problem that all of us face in the really in the coding exercise. Tips on the fixing errors. So finding errors is the one thing, but the most important thing, correct the errors, fix the errors, and when then the problem will vanish. Understand the problem before you fix it. I mean, the common thing, try people may not be able to, they don't know the problem, so they looked at the code and they are trying to say lots of things without knowing the original, the requirement. That is the what we call the problem. Understand the program, not just the problem. So it's a very important. Sometimes the problem will say one thing, the code will be on another thing. As I said, the problem based on the algorithm, but the algorithm could be implemented in a different way. That will lead to a kind of problem. So you need to see whether everything is aligned together, and that if that alignment is not there, requirement, design, algorithm comes out of the design, and the implementation. So these must be aligned. That is what I mentioned earlier, what we call the uh, track uh, tracing, forward tracing or backward tracing. That's very important. Confirm the error diagnosis. Okay, uh, and when an error occurs, there may be some sort of symptoms, and based on the symptoms you have to do a kind of an analysis. What is the root cause? So it is something like that. If someone has a fever, you can't judge the reason of the fever, so you have to do some sort of diagnosis to identify why someone is getting the fever. So like there may be an error. Just looking at the error, you can't say something. You have to do an analysis why this error has occurred. So that diagnosis has to be done. Relax. Okay. I think if we try to do the same thing continuously, I think it's the natural we become uh, very stressed up, and maybe it's just time to take a small break and try the same thing. Save the original source code. Keep the versioning as we discuss things under the Git and GitHub. If you don't keep these versions properly, sometimes we may have to go back to the original code, and we may mistake. So what we call the backtrack them. So Jet will provide that kind of facility. Fix the problem, not the symptom. Okay, so it's not taking a Panadol will not solve uh, the health problem. So you have to take the relevant medicine to fix the problem. So then the symptoms will vanish. Make one change at a time. Okay. Sometimes when people identify a list of the problems, they are trying to solve all the problems in a one go. That is not the correct. So try to correct one at a time, and follow the guideline in that way. Check your fixed. Okay. Sometimes the people correct the mistake, but they never go back and see whether what their correction is done in a correct way or not. So always whenever you modify the code, whenever you correct the mistakes, it's a very important to check again, and usually using the test cases which are identified, and make sure. So just correcting the some issues in the code is not enough. People need to check them, look for similar errors. Okay, if you observe an error, so there is a possibility similar thing could be happen in the somewhere else, and you can see. I think it's usually problems are spreading. Okay, there's like virus are spreading, so the errors are spreading in the code base. So when you detect something, be aware that the same thing could happen in the other places.